I'm Anil Kumar. Welcome to my series on IB Mathematics. We'll now review all the concepts learned about integration in this particular video with the help of a test paper. So here is the test paper from which I'm going to take up all the questions and then we'll discuss them one by one. Basically, we'll be solving few integrals using reverse of differentiation. The formula for normal polynomials will be x to the power of n integral will be x to the power of n plus 1 divided by n plus 1 plus c. N of course cannot be minus 1. For other standard formulas are given here, right? These are the functions, these are the integrals. You definitely need to add the value of c, right? Then we'll have questions based on area between the curves. Now in area between the curves, we'll also talk about, we'll have a question based on area between the curve and the x-axis, right? So one type of question will be finding area between the curve and the x-axis, right, in a given interval. The other type of questions could be area between two curves. For example, we could have a curve like this and another curve like this, where you need to figure out the point of intersections and then find area between the curve. So the basic formula for area between the curves will be this formula, but if you have only one curve, then the first part of the formula is valid. The second one will have x-axis, right? So the function g of x is x-axis, which will give you 0, right? Then we'll talk about volume. And when we talk about volume, it is basically for any curve, right, which is revolving about the x-axis, right? So when this curve revolves around the x-axis, right, so it'll be kind of like this, and what you really get is a solid shape, right? You get a solid shape like this, correct? So we'll talk about volume of these types of shapes, and the formula will be pi f of x squared d of x integral as given here. Now if you have any difficulties or any suggestions or questions, you can always send me an email on the given address. I'll definitely respond to your email at the earliest. Now let's look into these questions one by one. Question number 1 is, it is given that definite integral from 1 to 3 of f of x dx is equal to 5. Write down the value of definite integral from 1 to 3 of 2 times f of x dx. Part B is, find the value of this definite integral 3x squared plus f of x dx when the lower limit or lower bound is 1 and the upper is 3. You can always pause the video, answer these questions, and then look into my suggestions. Now as you understand, every definite integral will lead to a number as a solution, right? We are already given the number 5 representing this definite integral where the lower bound is 1 and the upper is 3. Now we need to find what happens when we multiply this by 2. Applying the normal rules and for definite integrals, 2 is a constant. So everything gets multiplied by 2. So this is basically equal to the definite integral from 1 to 3 of f of x dx. Now this integral is given to us as 5, so it results into 2 times 5 as 10, our answer. Perfect. So that is how you're going to solve part A. Now in part B, we could rewrite this definite integral as sum of integrals, right? So we can just write this as integral from 1 to 3 for 3x squared dx plus the integral from 1 to 3 for f of x dx. Clear? Now, to evaluate the first part, we can use antiderivatives, correct? So we could rewrite this as the antiderivative of 3x squared is what? X cubed over 3 times 3, right? So we could write this as 3 times x cubed over 3. Now we are given the limits from 1 to 3, right? Plus the second part we already know is equal to 5, so I'll write number 5 for that. To evaluate the first part, we can first simplify, cancelling the 3's, right? So what we get here is x cubed within 1 to 3 plus 5, and that is equal to 3 cubed minus 1 cube, right? So 3 cubed is 27 plus 5, right? So 3 cubed is 27. So we get 27 minus 1 plus 5. So that gives me 26 plus 5 as 31. So our answer here is 31, right? So our answer is equal to 31. So that is how we are going to solve it. So I hope the steps are absolutely clear. Now let's move on and take question number 2. Now here we'll discuss question number 2 with you, where we learn the concepts of derivatives and integration. The question here is, the velocity v in meters per second of a particle moving in straight line is given by v of t equals to e to the power of 3t minus 2, where t is the time in seconds. Find the acceleration of the particle at t equals to 1. B. At what value of t does the particle have a velocity of 22.3 meters per second? Well, it is no calculator, so leave your answer as the exact value. Part C is find the distance traveled in the first second. So the very first part, we are given that the velocity v is equal to e to the power of 3t minus 2. We need to find the acceleration of the particle at t equals to 1. So what is acceleration? Well, acceleration is the derivative of velocity, right? So we'll find the derivative of this. So derivative of exponential function. So it will be e to the power of 3t minus 2 times the derivative of the exponent, which is 3. So that's what you get, right? So 3 times this. Now if you need to find the acceleration at 1, t equals to 1, we'll substitute 1 here. So we get 3 times e to the power of 3 minus 1, which is 3, oh sorry, this is 3 minus 2, right? So we substitute 1, 3 times 1 is 3, 3 minus 2. So it gives us 3 to the power of 3 times e to the power of 1, which is 3, 3e. And so we get the acceleration at t equals to 1 as 3e meters per second square. Is that clear to you? Right? So that is how we are going to solve the very first one, part A. Now let's look into part B of this. It says, at what value of t does the particle have the velocity of 22.3? Well, we will now work with the velocity function as such. We have velocity as e to the power of 3t minus 2. We have been given velocity of 22.3. That should be equal to e to the power of 3t minus 2. To find the value of e, we can take natural log both sides, right? So we get ln 22.3 equals to ln e to the power of 3t minus 2, which is basically 3t minus 2, right? Since ln e is 1, so that is equals to ln 22.3. So from here you can calculate what t is. So you get t as ln 22.3 plus 2 divided by 3, right? That is the value of t. So we'll leave it at this stage since we are not allowed the calculator, right? So time t in seconds is for us Let's write down here. So t basically is equal to 2 plus ln 22.3 divided by 3 in seconds. Okay. Let's take part C on a fresh page. Find the distance traveled in the first second. Now to find the distance traveled, we need to integrate, right? So we are given the velocity as equal to e to the power of 3t minus 2. Distance traveled in first second, that means from 0 to 1, correct? So that is what it means. So we need to integrate this, right? So the I should say distance, it is a positive function, correct? So it is always increasing. Now since it is a positive function, the integral will also give you the area under the curve, which is the distance. So the distance will be integral of Vt dt from 0 to 1, which basically is from 0 to 1. So the definite integral for e to the power of 3t minus 2. Now we'll apply the antiderivative rules to find the solution. So we get this as the function e to the power of 3t minus 2 divided by 3. And we are going to look into the limits from 0 to 1, right? So that is equal to 1/3 of e to the power of, when you put 3 here, you get 3 minus 2, minus, when you put 0 here, you get 1 over 3 e to the power of minus 2, right? So the answer here is 1 over 3 e minus e to the power of minus 2. Okay? So that becomes the solution, and the units will be in meters. So I hope that makes sense. So that is how we are going to find the total distance traveled in the first second. Perfect. So here is question number 3 from one of my students' test paper, IB question paper it is. Let me thank all my students for sharing their test papers with me and doing fairly well. We'll actually have 2 related questions based on the integral of 1 over 2x plus 3. Let's look into 3a first. It is find integral of 1 over 2x plus 3. Now, you can always pause the video, answer this question, and then look into my suggestions. Let's apply the method of substitution to find this integral, right? So what we will do here is that we'll substitute, let u equals to 2x plus 3. In that case, taking the derivative, what do we get? We get du dx equals to 2, or we can say that we have to replace that dx, so we can say half of du equals to dx, correct? So we are going to make this substitution here, and we can write this integral as integral of, so we are replacing 1 over 2x plus 3 as u, so we get 1 over u, and dx is being replaced by half du, right? So that's how we get our integral, and now we can write this as half of integral 1 over u du, okay? And that gives you half of ln u, right, plus c. So that becomes the integral, and now we can replace u with 2x plus 3. So what we get here is half of ln 2x plus 3 plus c as our answer. Is that clear? So that is how you should be doing. But remember one thing, that when you write ln u, you have to take the positive value. Now since 2x plus 3 could be negative also. Now ln is not defined for less than 0 or even equal to 0. So we have to take its is positive value, so that is very important to write. So that is not to be missed, correct? So the actual answer should be ln absolute value of 2x plus 3 half, right? So that's kind of important to understand. Since 2x plus 3 could actually take any value. Well, 2x plus 3 will not be 0, right? But it could be negative or positive, right? It is never equal to 0. So that is what you should be writing as your answer, right? I hope that makes sense. Kind of important to understand. So let me put a star here, since I've seen many students missing on absolute value. So the integral of 1 over u is basically ln absolute value of u, correct? 2x plus 3 plus c. We're going to use this to solve part B, which is, given that definite integral from 0 to 3 of 1 over 2x plus 3 dx is ln square root p. Find the value of p, right? So we can write this as ln square root p is now given to us as equal to the definite integral from 0 to 3 of 1 over 2x plus 3 dx. Well, we just found what this is. It is basically equal to half of ln absolute value of 2x plus 3. Now we are given the limits, lower 0, upper 3. So now we can calculate. So ln square root p can be written as half ln p, and here we have what? We have half, let's put brackets, ln absolute value of 2 times 3 plus 3 minus ln absolute value of 2 times 0 plus 3. Correct? So we get half of ln p equals to half of, so this is ln 6 plus 3 is 9 minus ln 3. Right? We can cancel this half and half. So what do you get? We get ln p equals to, well, when it is written like this, you can always say it is ln 9 over 3 using the properties, which is ln 3. So ln p is equals to ln 3, and that gives you the result that p is equal to 3. Is that clear to you? So that is how we can actually solve this question. So here is question number 4, which we are going to now solve. The question here is, the graph of function f of x equals to p cos x is given to you. Find area of shaded region. So that's the graph. Now you can always pause the video and answer this question. Now from the graph, we know what p is. P should be 3, right? Looking at the graph. So the function f of x can be written as, which is given to us as p cos x, can be written as 3 cos x. So the function is 3 cos x, since the maximum value given to us is 3. Now we need to find the area of the shaded region. That means from 0 to pi by 2. So that much area we need to find. So the area is how much? Area can be written as a definite integral between 0 to the interval, which is pi by 2, for the given function p cos x. P is 3, so 3 cos x dx. Now in this case, the integral should be what? So the integral is 3 cos x sin x integral, right? And the interval given to us is from 0 to pi by 2. So we can now calculate this value as equal to, well, 3 is a constant, we can write constant outside, and sine of pi by 2 minus sine of 0, right, radians. Now this is equal to 3. Sine of pi by 2 is 1 and sine of 0 is 0. So that gives us a value of 3 square units or unit square. So the answer here is that the area equals to 3 units square. Perfect. So that is how you could solve it. Now here is another test question on integrals to find area defined by intersection of few lines or curves. The question number 5 here is, using integrals, find the area of the triangle formed by positive x-axis and tangent and normal to the circle x square plus y square equals to 4 at 1 square root 3. You can always pause the video and answer the question. Well, let's see the scenario first. So here is a circle whose equation is given to us as x square plus y square equals to 4. It means it has radius of 2 and the center is at 0, right? So at the origin. So that becomes the circle, radius being 2. So this point 1 will be somewhere there. So we can actually draw a tangent, right? So that becomes the tangent. Normal at this point will be the line joining from the origin itself. So as you know, radius is always at right angles to the tangent, right? So this angle here is right angles. So we have two lines. Let's call this line as L1 and the other line as L2. This point is 0. The point given to this place is 1 square root 3. So the equation of line 1 is what? Equation of line 1 will be a direct variation going from 0 to this. We could say this is y equals to square root 3x. Square root 3x, right? So y equals to square root 3x is equation of line 1. To find the equation of tangent, which is line 2 for us, which is tangent, the slope has to be negative reciprocal. So slope of tangent is going to be negative 1 over square root 3. We can write its equation as y minus y1, which is square root 3, equals to the slope, which is minus 1 over square root 3, x minus x1, which is 1. So that becomes the equation of line 2. We really want to find the x-intercept, since the area formed by the x-axis, that is your x-axis, the normal, right, let's call this point P, and the x-intercept, which is, let's say, Q. So we are looking into the area of triangle OPQ, correct? That is what we are interested in. So we need to find what this point Q is. Well, at Q, y is 0. So to find Q, we'll substitute 0 for y. So 0 equals to minus square root 3 equals to minus 1 over square root 3 times x minus 1. Cross multiply to solve. With negative 1, if we multiply, we get 3 equals to x minus 1, or x is equals to 3 plus 1, which is equal to 4. So the point Q is at 4. Correct? So we got the value at this point Q also. So now we have two lines. Let me summarize here. Line 1, which is y equals to square root 3x, and then we have line 2, whose equation can be written as, let's write it in a better form, right? So we rewrite the equation of line L2. So y equals to the slope, which is minus 1 over square root 3 x plus b. To get the value of b, find the value of b, let us put this point 1 square root 3. So we get square root 3 equals to minus 1 over square root 3, x is 1, plus b. So the value of b will be square root 3 plus 1 over square root 3, which gives us square root 3, 3 plus 1, or we get a value of b as 4 over square root 3, correct? So the line 2 will be y equals to minus 1 over square root 3x plus 4 over square root 3. Clear? So that becomes the equation of the second line, which is the tangent, right? So this is the tangent for you. And then we have the first equation is for the normal. Now, let us find the integral to get the area of the triangle OPQ. Good. And let's do it on a fresh page. So what we have learned so far is that that's a triangle, or that's a circle for us with center at the origin. The equation of normal being y equals to square root of 3x, and the equation of the tangent, this point here is 4, and the equation of the tangent is y equals to minus 1 over square root 3x plus 4 over square root 3, correct? So those are the two lines. We are now interested in finding the area between OP and Q using integrals, right? Okay. So the area of triangle OPQ can be given as the integral from 0 to 1. So here, as you can see, till 1, we are looking for a curve area under the straight line y equals to square root 3x, right? So it is y equals to square root 3x dx from 0 to 1 plus integral 1 to 4, the curve under the tangent line, which is minus 1 over square root 3x plus 4 over square root 3 dx. Correct? So that should give us the total area, right? Now, the area of this is square root 3 x square over 2 within 0 to 1, right? Plus the area here is, so we could write this as minus 1 over square root 3 times x square over 2. Now this is a constant, so it will be 4x square root 3, okay, from 1 to 4, clear? So that becomes the area. So let's substitute the values. We could write like this, right? Square root 3, x equals to 1, 1 minus 0 is just 1, so we get times half here, plus, when you substitute 4 here, you get minus 1 over 2 square root 3 times 4 square is 16, right? Minus, when you substitute 1, that minus and minus becomes positive, and you get 1 over 2 square root 3. For 4x, we get 4 times 4, 16. So let me write this as 16 over square root 3 minus, when you substitute 1, you get 4 over square root 3. Correct? So that becomes the area. So we get here square root 3 over 2 plus, we can take 1 over 2 square root 3 rather common, right? And then we'll add all those other terms. So we'll take 1 over 2 square root 3 common. So we have minus 16 here, plus 1. Here we get plus 2 times 16, which is 32. And here we get 2 times 4, which is minus 8, right? So adding this, we get square root 3 over 2 plus 1 over 2 square root 3. And here we get Uh, taking away 16 gives us 16, and then 8. We get 8 plus 1. We get 7. We get 9, right? So we get 9 within the brackets. So now we can simplify this. That gives us, taking 2 square root 3 as common, right? Let's take 2 square root 3 as common. Multiplying here, we get 3 plus 9, which is 12 over 2 square root 3, or 6 over square root 3. Now this could be rationalized. So you could multiply and divide by square root 3. So you get 6 square root 3 over 3, or this could be written as 2 square root 3. Correct? So this could be written as 2 square root 3. So that becomes the area. Perfect. So our answer here is that area equals to 2 square root 3 units square. Correct? So that is how you can actually solve this question. In this video, we'll discuss how to find a formula for volume of a sphere. Well, you know that the volume of the sphere V is given as 4 by 3 pi r cube, where r is the radius of a sphere. Now using integrals, we'll actually figure out how to derive this formula. So here we have a sphere. Now let us consider the origin to be the center of the sphere. So I'll draw my y-axis vertical going through the diameter, and x also through a diameter, but horizontal this time, right? So we have these two x's. So that becomes a sphere with center at origin, right? Okay. And any point on the sphere is at a distance of r, right? Now it looks like a circle, but it is, imagine, a three-dimensional sphere. Now let us say we slice the sphere with a plane through this point. If we cut a slice out of the sphere, how will it look like? Well, it will definitely look like a circular disc, right? So it will look like a circular disc, which could be shown as like this. Correct? Now it gives you more of a look of a sphere, right? So what we have done here is that we have cut a slice. So that is a slice out of this sphere. So that becomes the height of this slice, which we can say is, let us say, y. And let us say that we have cut this slice x distance away, right? So this distance from here, center, to the point where we have cut the slice is x distance away. Now in this particular case, we can find a relation between radius y and x, correct? So from here we can say radius r is basically equal to y square plus x square, right? We can say r square is equal to y square x square. Okay, so that relates r, x and y at any instance of time, where we know that r, which is the radius, is a constant. Correct? Now, as far as this slice is concerned, let's look into this slice in more details. So let's say we have this slice, which is a disk, right, of a thickness. Let's give some thickness to this disk. So what is the area of this? Now, as shown here in the figure, y could be the radius of this circular disk, right? So this is what we have here is a circular disk. Right. Here, the radius is y, right? So area of this disk is how much? Area, since it is a circle, will be pi y square, since y is the radius of this. Correct? Now, if I give some thickness to this, let's say delta x is my thickness of this particular disk, in that case, let's call this as thickness of delta x, right? In that case, the volume will be how much? Volume will be equal to pi y square times delta x. Correct? That small thickness. Then we get the volume of this disk. Now think about our sphere cut into infinite disk of this form, right? So if we cut slices of disk with thickness of delta x each, correct? Then what happens? Then sum of volume of these disks will be the volume of the sphere. Is that clear? Right. So if we cut into such disks, many of them, right, and then add their volumes, then we get the total volume of the sphere, correct? So we can say that the volume of sphere is, we can write the sum as sigma notation, right? This is like sum of volume of each disk, right? So each disk is pi y square delta x, correct? Pi y square delta s, where the value of y actually changes with the value of x as we move along it, right? So we can find what this y is. So from this relation, we can say that y square is basically equal to r square minus x square, correct? So y becomes a function of x, r is constant, right? R is constant. So we can say that this is equal to the sum when x is changing from this place here will be minus r and this place will be r. So what is varying here? Basically, as you move along, it is the x value which changes from minus r to plus r. From minus r to plus r. You understand now? Y is a function of x, right? Clear? Y is a function of x. So we can write this volume of a sphere as equal to pi, instead of y square, let me write this as r square minus x square times delta x, right? These small slices with thickness of delta x, which is constant, right? And x is varying from minus r to plus r. Is that clear to you? Right? Now, if we have infinitely large number of disks, right, for infinitely large number of disks, what happens? Delta x will be approaching 0, right? And what we get here is the integral sum of these disks, right? So we could now write this as integral from minus r to plus r of all this, which is pi r square minus x square delta x. Perfect. So that is how we can actually calculate the volume of this sphere. Now on the next page, we'll work out this integral and find the formula. I hope that sounds good. So let me just redraw this diagram, right? So we took the sphere, center at the origin. We are considering a particular disk here, sliced away from at a distance of x units from the center, right? So that's the disk which we have sliced away, and we know it is at a distance of r units, correct? And let's consider the height here as y, which is x distance away from the origin, correct? And we also figure out that the volume could be written as the integral from minus r to plus r, right? So that those are the two extremes which x value can take, from minus r to plus r. Area of each disk is pi r square, right? So pi radius is y, and we found that y is basically what? Y is equal to, you can say y square is basically equal to r square minus x square, correct? So we replaced this y here with r square minus x square, and delta x is a small increment, right? Multiplying with delta x gives volume of each disk, right? You can think about a cylinder with circular area of pi r square and a width of delta x, right? So this integral gives us the volume of sphere. Perfect. Now let's continue. Now this integrand here is symmetric, right? It has even symmetry, correct? So the integrand has even symmetry, correct? And therefore we can say that this is equal to from 0 to r 2 times, right? 2 times pi r square minus x square dx. Perfect. Now the integral will be, pi is a constant, so we get 2 pi, and the integral of this portion is what? R square x minus x cube over 3, and the lower bound is 0 for us, the upper bound is r. Right? Now let's substitute the values. We get 2 pi. Here we get r square times r minus r cube over 3. Right? So if you calculate this, you get 2 pi 3r cube minus r cube over 3. 3 minus 1 is 2. So we get this as 2 pi by 3, and the bracket we have 2 r cube, which is multiplying, we get 4 pi r cube over 3. Over 3. So we have our formula, 4 by 3 pi r cube. So we have derived the formula that the volume of the sphere equals to 4 by 3 pi r cube, right? Since r is a constant, the integral will be r square times x, right, for r square. And for x square, it is varying, right? So it will be r x cube over 3. Substituting the value of r, minus 0 is 0. So we get our formula. Is that clear to you? So by addition of these disks, we found the formula for the volume of a sphere. So I hope you understand and appreciate all these steps. So the question for us is, find area under the curve f of x equals to 9x minus x cube for x greater than equal to 0 and less than equal to 3 using limits. Evaluate definite integral from 0 to 3, 9x minus x cube dx to compare the result. You can actually pause the video, answer the question, and then look into my suggestions. Now, the idea here is to use both the methods of finding area and see how close we are to the results. So when I'm saying that the function f of x is 9x minus x cube, I could factor this as x. If I factor, I get 9 minus x square, right? Which I could also write as minus of x, x minus 3 times x plus 3, correct? So in limited space, we'll try to squeeze in the solution. That means a cubic function, leading coefficient negative means going downwards, right? So kind of like this. So the graph will be something like this. Okay. We need to find the area between 0 to 3. So this will be 3 for us. So the in between 0 to 3, this interval will be divided into series of rectangles, correct? And we are going to have n rectangles in this series. Let us see what is going to be the width of each rectangle. So let's say width is delta x. Then we need to figure out what is this width. So delta x is going to be 3 minus 0 divided by n. So that will be 3 over n. So basically it means that each rectangle is spaced so that the right hand corner of the rectangle is 3 over n units away. So the first one will be at 3 over n, correct? The second one will be where? 2 times 3 over n, right? 2 times 3 over n, correct? So if I have this one, which I am saying the ith one, right, will be I times 3 over n, correct? So this will be ith one, right? So here the function value will be f of xi, correct? So in general, right, where I now can vary from 0 to n, right? So this will be xn, correct? Last one. Now, so what we discovered here was that end point of each, which is xi, is now basically for us I times 3 over n. So we get the area. Area of each rectangle can be written as what? Area will be sum of these rectangles. We'll say sum of these rectangles, where I goes from 1 to n. We are taking the right hand side, right? So we are using right hand corner. Of each rectangle. Right? Now, so f of xi times delta x is constant for each. Now this area will be very close to the real value when n is approaching infinitely large number. So that gives us the formula to figure out the area. Clear? Now let's use this formula and find the area. So we have limit n approaches infinitely large, sigma, sum of all rectangles, 1 to n. F of xi means we'll replace x with xi, right? So we have 9xi minus xi cube, right? Now, for us, xi is 3 times I over n. So we can write this as limit n approaches infinity sigma I equals to 1 to n, times delta x, right, width. That becomes the area, right? So fxi is this length, correct? This is fxi times delta x. So what you get here is xi is 3I over n, right? So we get here 9 times 3I over n minus 3I over n whole cube, everything, times delta x. Delta x is 3 over n. Okay, so that's what you get. So now you can write this as limit n approaches infinitely large, sum I equals to 1 to n, 3 times 9 is 27, I, and we'll open this. Rather, we can actually multiply by 3 also, right? So over n times 3 over n. So we are just multiplying with this 3 over n also. So minus, this gives us 9I, cube, right? So it is 27 I cube over n cube times 3 over n. So we multiplied by 3 over n. Okay, so that gives us limit n approaches infinity for I equals to 1 to n. So when you multiply, you get 3 times 3, 9, 9 times 9, 81 I over n square minus 27 times 3 is 81 I cube over n cube and n to the power of 4. Clear? Now, 81 over n square or 81 over n to the power of 4 is independent of I. So we could write this as limit n approaches infinity 81 over n square sigma of I, where I changes from 1 to n, minus, let's put this in brackets, 81 over n to the power of 4 sigma of I 1 to n for I cube. So we can now use the formula for sum of natural numbers and sum of cubes of natural numbers, right? So using those formulas, we can now write down this as limit n approaches infinitely large. We have 81 over n square times sum of natural numbers is n times n plus 1 over 2 minus 81 over n to the power of 4, and here we have n times n plus 1 over 2 whole square, correct? Now let's simplify this. All this is to the limit n approaches infinity. So we have limit n approaches infinitely large, taking n square inside, we get what? We get 81 over 2, and here we get n square plus n over n square minus 81 over 4. Okay, now 2 square was 4, so we are taking this outside, and n to the power of 4 we are taking n square inside. So we'll write n times n plus 1 over n square, right? Whole square. Now, limit n approaches infinity. So that gives us limit n approaches infinitely large. Now in this part, you will say n square over n square is 1. So we get 1 plus 1 over n. So what we get here is 81 over 2 times 1 plus 1 over n minus 81 over 4. And here again we get the same thing, 1 plus 1 over n whole square, correct? Now as you can see, as n approaches infinity, 1 over n approaches 0, right? So So 1 over n approaches 0 when n approaches infinitely large, correct? So now you can write this as 81 over 2, right? That is 81 over 2 times 1 minus 81 over 4. So we can take 4 common. We get 81 2 minus 1, which is 81 over 4. So 81 over 4 is basically the area under the curve from 0 to 3, right? Unit square. So what we find that this area is basically equal to 81 over 4 unit square. Is that clear? Right? So the only thing is that you should remember the formulas for sum of natural numbers and these formulas, right? Which we have directly written here, right? So those are the formulas. They are must. And then you can simplify and get your result. Perfect. Now, let us verify using integrals, right? So we need to find integral of the same function from 0 to 3. So this could be written as what? So the integral we are doing from 0 to 3 for 9x minus x cubed dx, correct? So that is 9x square over 2 minus x to the power of 4 over 4 from 0 to 3. So if I write 3 here, I get 9, 3 square over 2 minus 3 to the power of 4 over 4. And that gives you 9 times 9 is 81 over 2 minus 3 to the power of 4 is again 81 over 4. We get exactly the same result, right? We can take 4 common. So 81, 2 minus 1, which is 81 over 4 unit square. Do you see that? So we get exactly same result. Do you see that? So we get exactly same result, right? So you can see how the two methods provide you with exactly same result. So they are the right ways of doing area under a curve. So when n approaches infinitely large, so the concept here was the summation of the areas I 1 to n, where the limit n approaches infinity, that is kind of critical, for f of x I times delta x is basically equal to definite integral from, so it depends what interval you're doing, right? Say interval is from a to b, for example, right? In general, we can write from a to b for f of xi times delta x dx. So this formula works, right? So that is a great connection between the limits and the definite integrals. And of course, definite integrals is a much simpler way of finding the area under the curve. So I hope the concept is clear to you. Here is another excellent question from IB test paper. So we'll do question number 6 in this test paper, which is going to be question number 7 for us. Find the area of the region enclosed by curve y equals to x plus 2 and y equals to x square plus x minus 2. Graph each function and the shaded region after obtaining the points of intersection. You can always pause the video and answer the question. So let's first find the point of intersection between these two curves. So we are given y equals to x plus 2, and we are also given that y is equal to x square plus x minus 2. So at the point of intersection, these two values should be same. So we'll write x plus 2 equals to x squared plus x minus 2. Bringing them together, we can write 0 equals to x squared plus x minus 2 minus x minus 2. And that gives us x squared plus x minus x cancels and we get minus 4. So that gives us two values of x. So x is equal to plus minus 2, right? Square root of 4. So these are the 2 points of intersections. Now we will sketch both the graphs. Let me make a small sketch here. Then we'll find the area on the right side. So one of the curve is a straight line, y equals to x plus 2, right? So let's say this is 1, this is 2. So we'll just draw a straight line here. So our drawings will be slightly approximate, right? But I hope they'll give you a fairly good idea about what we're trying to do. So this point here is the intercept is at minus 2. Here the y-intercept is at plus 2. The points of intersection between the parabola and the line are at plus minus 2. That means one of this point is here. The other one will be on this side, right? So let's say this is 1. So at 2, somewhere here, right? Somewhere here. Okay. Now let's look into the second equation, which is x squared plus x minus 2. The equation x squared minus x minus 2 can be factored, and we can write this as x plus 2 times x minus 1, right? So that means we have a 0 at minus 2 as expected, and the other one is at 1, right? So we have two zeros for this parabola. So the vertex will be somewhere along this line. So let me just sketch a parabola here, going through these points and then through the intersection. Does make sense to you, right? So this point is the point of intersection for x equals to 2, correct? Area between the curves will be this shaded portion, clear? So we want to find area of this curve. So definitely the area of this curve is, you can write this function minus the other function, right? So to find the area, we can say that area of the curve will be equal to area between these two x values, that is integral from minus 2 to 2, and the function is going to be the linear function, which is x plus 2, take away the parabola, right? So region between these two, which is x squared plus x minus 2 dx, correct? So that becomes the area under the curve. Let's try to simplify this. So what we get here is integral from minus 2 to 2. We have x plus 2 minus x squared minus x plus 2, right? dx. That is integral from minus 2 to 2. And this gives us x and x cancel. We get minus x squared, and 2 plus 2 is 4. So we get minus x squared plus 4. Right. The integral of this will be x cubed. Let's write down here. So we have minus of x cubed over 3 plus 4x from minus 2 to 2. Right? Substitute these values. So when you substitute these values, we get this as equal to minus of 2 cube. Okay, so minus of 2 cube, the denominator, let's write down here, minus, so minus and minus becomes plus, right? Because the cube will be negative of 2 cube over 3, and for this we get plus 4 times 2 minus of minus 2 will be plus 2, right? So that becomes the integral for us. So this minus we'll take outside actually. 2 cube will give us a negative value. Let me write minus like this, right? So which is equal to 8 and 8, 16. So we get minus 16 over 3. And that is 2 and 2, 4. 4 times 4 as 16, right? So we get this, which is basically equal to 3 common denominator minus 16 plus 3 times 16, which is 48. And so we get 2 times 16, 32 over 3 as our answer, right? So 32 over 3 units square we can write. Clear? So that is how we can actually find the area of the region between these two curves. Clear? So I hope the solution is okay. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.